First, let me introduce myself. I'm Erik Schrier, Senior Account Manager at ICOCamp and also Product Manager Water Quality. I have my background management as a middle-aged school and on high school water treatment. I worked 25 years for consultancy companies like Tau and Takedis, and since September 20 ICOCamp. Let me first tell you something about our change from Aquaread to the Royal ICOCamp Scuba probes. We want to grow our presence in water quality by improving and expanding our current offering. We are launching a new probe that carries our name, Royal ICOCamp Scuba. This is our first step of a roadmap for integrated solutions, which include hardware, software, telemetry, and services. We are investing heavily in creating new software features and platforms that don't exist today in the market, allowing our users to integrate more than just sensors. One of the unique buying reasons is your warranty on the probes. We change from Aquaread to the new manufacturer because they can take us where we want to go from a technical and integration perspective. Aquaread could not be the partner for the future we are working on. Customers who already have Aquaread probes will be serviced. We won't sell new probes anymore to the customers. If this can lead, please contact our service department for more information and support via service@icocamp.com. All new questions for water quality probes will be filled in with the new Royal ICOCamp Scuba probes. The content of this webinar is the following points: the selling features of the Scuba probes, customers' questions and their applications, a short questionnaire list, our probes and sensors with the accessories and the software, the needed energy source, also the article numbers and pricing, and our support to you. What are the selling features of our Scuba probes? They are rugged, intelligent, and simple. And let me explain that just a bit. Rugged because they are anti-corrosive housing and sensors. Industry-leading 3-year warranty for open all sensors except the ESA. The sensor lifetime is over 5 years except the ISE, and ISE stands for Ion Selective Electrodes. Replaceable DO cap and ISE sensor tips, refillable pH reference electrode, and anti-fouling options like a wiper, central wiper, and copper gauze. And especially the refillable pH reference electrode is a big step forward, even as the 3-year warranty and the longer lifetime of the sensors. And with that, we hope that we have a lot of success with our Scuba probes in the market. They are also intelligent. And why? Because they have a sensor health indicator, and you can recognize that as a standard response factor during the calibration. From the main manufacturer, standard response is 100% or some higher. And during the lifetime, the standard response factor can decline. So that gives you a better indication what is the health of my sensor. Also, automatic recording of internal calibration data during the calibration, and it has a LED status indicator. They are simple, one touch and automatic data capture, fast, easy calibration, intuitive software, and it operates on Windows, Android, or iOS platforms. The customer questions. Okay, who are our customers and what do they want to measure? Our customers are mostly water boards, municipalities, universities, knowledge institutes, schools, consultants, field workers, but also farmers in aquaculture, fish farms, and industries. What do they want to measure? Normally the basic parameters like temperature, electrical conductivity, dissolved oxygen, pH, or P redox, also known as oxidation reduction potential, turbidity, and also special parameters like algae, blue-green algae, chlorophyll A, nutrients like ammonia or nitrate, tryptophan, oil, photosynthetic light, abbreviated by PAR, and also tracing fluids. But sometimes there are also other parameters, and we can help them with it. What are their applications? Where they want to measure? In surface water, for agriculture, recreation, and dredging. Agriculture, for instance, the leaching of nutrients coming out of the land in the water. Also recreation, more and more cities do have swimming competitions in open water. But also dredging can disturb the water quality because of a lot of turbidity from particles. Also stormwater is an application. As a result of stormwater and rainfall, there could be an overflow of sewage. Sewage overflows in the surface water. And that could decline the oxygen concentration in the surface water. And that can affect, of course, death of fishes. Also, a fish farm can be an application for measuring oxygen and, for instance, turbidity or nitrogens. Tracing is another application that can be asked for. Tracing for flow velocity of a channel of water in a channel, and you can measure that with injecting a dye like fluorescein to measure the flow velocity. And also another application is the discharge of wastewater from wastewater treatment plants or discharge from industries, wastewater from industries. So for that applications, the questions are also why? Why do they want to measure? To know water quality, of course, but why? Because of the healthy water environment for flora, fish, and people, and also because of standards in water legislation. And why? Because sometimes they want to reduce use of fertilizers in agriculture, for instance, the farmers or the water boards who are responsible for the quality of the surface water. Sometimes they do want to reduce the sewage overflows or to prevent algae blooms, and also to optimize fish growth and do process control. What and how do they want to measure? Do they want to measure a trend or a spot? So trend measuring in time, over time, during 1 year, during day, or just spot measuring. And how do they want to collect the data? Do they want to receive them online, unattended, in a data logger, or manually? In this table, I have summarized the 4 possible ways to collect the data: by single point profiling, unattended logging, so just put the probe in the water for some time and log all the data inside the probe, or just active monitoring, single point measurements, and also telemetric deployment to collect data during time, weeks, days, or longer. At the option of the single point measurement for groundwater, I've set up a mark for the flow cell. From our manufacturer, it is not allowed to use the flow cell with the Scuba probe together with low flow pumping for groundwater. It's one of our exceptions in our contract with the manufacturer. Also, another question is how long, how frequent, and how will the customer receive the data? How long? For 1 day, 1 month, 1 year, or longer than a year? And receiving data in a log file or online. Both options are easily with our probes. Normally, we sell our probes like product as a service, but more and more the question comes up from customers to deliver data as a service. And also with these probes, you can deliver data online or manually. To structure all the questions which we have to send over to our customer, we have made a questionnaire list to make it more easy for you to fill in all the information we need to choose the right parameters and also the right probe for the right application. And if we use this questionnaire list, we get a clear overview of all the demands of the customers. After the meeting, after the webinar, we will send this questionnaire to you by ready, and we will set on ready, upload all the information you need. It's just an handy tool to funnel all the questions to the right probe. Here's an overview of all our Scuba probes. The Scuba line consists of 6 probes, 6 standard probes, from the 3 meter, the Scuba 50, Scuba 65, Scuba 75, the 90, and the numbers behind the Scuba are the numbers in millimeters. That is the Scuba 3 meter can consist a lot of sensors, only 3, and excluding the ISE. On the right side, I've mentioned the parameters which you can measure with the probes. These are standard probes, but within the standard probes, then can be made a variation which sensor will be in or will be out. So if you have a deviation from the standard and you will put in another sensor, you can do that. Which parameters and sensors can be in the probe and can be measured by the probe? The standard parameters like temperature, electroconductivity, pH, or P, dissolved oxygen, turbidity, and depth. ORP and depth are marked with 2 stars because they are optional. They are not standard in the probe. So if you like to have pH and ORP together, then you can remove the pH sensor, and instead of that, you can put in the pH in combination with the ORP sensor. Also, parameters by fluorometric sensors. They are the blue-green algae, the chlorophyll A, rhodamine, the fluorescein, the refined oil, chromophore, abbreviated as CDOM or FDOM. You can also measure PTSA, tryptophan, PAR, optical brightness, and crude oil. Tryptophan, for instance, is a parameter, is an amino acid that you can measure as a guide parameter for the presence of E. coli bacteria, which can be in the water overflow. Parameters that can be measured by the ISE sensors are ammonium, nitrate, chloride, calcium, natrium, total dissolved gas, and also bromide. Bromide, for instance, is a guide parameter for fertilizers. Other parameters that can be not measured but can be calculated based on electrical conductivity are salinity and total dissolved solids. More information about our sensors will become available on our new website. In the next two sheets, I have summarized the sensor specifications. So that means the sensor, the parameter the sensor measures, the range, measurement range and the units, accuracy, and also some comments for the sensors. For all sensors, there's a remark: for best accuracy, always calibrate near the anticipated field readings and near the temperature of the anticipated field readings. Specifications indicate typical performance and are subject to change. Here's the second sheet for the sensor specifications for the fluorometers, ion selective electrodes, the PAR and the carbon dioxide sensor. To help you to choose the right probe, we have made an overview called the Scuba standard probe configuration. This overview gives you insight in which probes do we have in the standard package and also which sensor are in it. Be aware that a lot of sensors can be removed and replaced by others. For the Scuba 75 and the 90, we have an A and a B version, and the difference you can see on the configuration sheet. The Scuba 90 and the Scuba 105 are the largest probes, which can contain small and medium sensors. And in the box in the right corner, we have deviated what small and medium is. Small are the IC sensors, the medium are the fluorometer sensors. Mostly the Scuba 105 is asked by customers like universities for science, because they can have a lot of sensors in it, and mostly the clients ask for the Scuba 90 or the Scuba 50 or the Scuba 65 and the 3 meter. And more also clients ask us for here's a bigger picture of our probe. In this case, it's the biggest Manta, the Scuba, and the Scuba is available with up to 12 sensors. As you see, there are ion selective electrodes, optical DO sensors, fluorometers, turbidity, and a central wiper system. The central wiper system is connected to the wiper of the turbidity sensor, and the wiper of the turbidity sensor is a rubber one, and the central wiper system has a hairy wiper. In the next a couple of sheets, I have summarized for all probes the most important characteristics as length, diameter, the power supply, data memory, and also some accessories, and also the composition of the probe, which sensor can put in it. Be aware that in the Scuba 3 meter, no IEC are available because they need the electroconductivity probe for measuring the ion activity. pH and ORP is available in this probe, and temperature and depth are optional. Pay attention to the large data memory, about 1 million readings. Here's an overview of the Scuba 50, the Scuba 65, the Scuba 75, A and B, the Scuba 90, A and B, and a Scuba 105. In this sheet, there's an overview of the Scuba basic components. In the middle, we have the Scuba probe, together with the underwater cable, that's the black cable. On the left side, there is the connector to connect to the probe. And on the right side, we have the connector, the RS232 connector, which can connect to, for instance, a PLC, or can connect to your PC or laptop. To connect the probe to your laptop, you need a transformer, which consists of the RS232 and a USB connector. Together with the USB cable, you can connect it to your laptop, your PC. Also, there is a weighted guard, which can put on if you want to place the probe in the water and give it some more weight to prevent flowing up of the meter. There's also a screw set. There's the standard screwdriver and some other screwdrivers for little screws inside the probe. There's also a calibration cup. This is the right one. If you want to calibrate the probe, just put on the probe with the sensors on top, put on the calibration cup, remove the black covered the top, and then you have an open space to the sensors where you can put in the calibration fluid. All information about the sensor, like manuals and other stuff, we have put it on the software USB stick, so that you always in the field have the right manuals together with your probe. How is the probe sourced with energy? There are some possibilities. One is the Scuba Mobile. The Scuba Mobile is a battery and also a Bluetooth device. So one is for energy delivering to the probe, and the other function is connecting with Bluetooth to an iOS device like Apple phone. The other one is the Bluetooth battery. That's a temporary one, special for Android devices. Later on this year, we expect before summer or just after summer, we have finished the Scuba Mobile for the Android version. We also have an internal battery pack. The internal battery pack is solid inside the probe and can be filled with batteries. The other option is the external battery pack that is connectable to the probe. So if you have an external battery pack, you are more flexible than an internal battery pack, because you can disconnect the external battery pack and connect the probe to, for instance, a solar panel. On the right, you see the solar panel and a 12-volt battery to feed the probe by solar. In this sheet, I have some detail about the internal battery pack. All Scubas can be ordered with an optional internal battery pack. This is a watertight housing with the cassette for batteries, which permanently. One remark: do not use lithium batteries in any Scuba battery pack. The other detail is about the external battery pack. All Scuba the optional external battery pack, except the Scuba 90 and the Scuba 105, because they have only an internal battery pack. Also removed from the Scuba. Do not use lithium batteries also in any Scuba battery pack. Together with the probe, we have also some accessories for every application. Here I have some accessories which are most important, but there are a lot more. But for this exercise, I will pay some extra attention. The first one is the SDI12 connection. It's been used for RS232 to SDI12. In the probe itself, there can be SDI12 put in on the computer board. That must be chosen as an extra option for the probes. Standard is a probe without SDI12. The SDI12 connection will deliver it with open ends or together with a connector, just what you want. The probes can be covered in a case. It could be a hard case or a soft carry case, and the soft carry case is a backpack. Also, we have cable reel. For instance, when you have and you want to carry it easy in the field, you can use the cable reel to wind it and to rewind it. Also, there are calibration fluids for all sensors. There's a flow through cell, but not in combination with low flow pumping of groundwater. Also, you see here the PC connection tool. PC connection is also for your laptop. And we have the ability to have copper gauze around the sensors to prevent biofouling. As said, controlling sensor fouling, we have several options. We have a central wiper, we have copper gauze, and we have a special wiper on a turbidity sensor. The central wiper is a hairy one and only available for the Scuba 75, the 90, and the 105. The copper gauze can be placed on any sensor. The central wiper without turbidity sensor can be placed in the case that you want to remove the turbidity sensor and to put in a wiper for all the sensors which are in the outer circle of the probe. If you only want to have a turbidity sensor, for instance in a 3 meter, then there is a wiper on the turbidity sensor. It's integrated. The last 2 months we have done a test for about 7 weeks with the Scuba 90 because we were curious how the copper gauze would affect, would prevent the fouling and how the wipers would work. As you see, after 7 weeks we have lifted the probe and took a picture, and in more detail we have put a picture from the copper gauze, and as you see, the copper color because of the copper oxides, and especially the copper has some little toxic effect on bacteria and also bacteria and little microorganisms to prevent biofouling. And on the right side you see a picture without cleaning manually, only with a wiper, what the result of the sensors is after 7 weeks. And as you see, all the sensors are still clean. They are where they needed to be clean for the measurement. So we have asked ourselves, okay, how stable is in this case the sensor, for instance, for turbidity and EC? And for that question, the answer on that question, I've put in a little graph with the results of the electrical conductivity and the turbidity. The EC is the line in gray, and in purple, there's the line for the turbidity. All the dips or the decline in concentrations are a result of rainfall. The larger the dip is, the declining, the heavier the rainfall. In the period from end of January, there was a lot of rain. And that was also affecting the turbidity of the surface water in the ditch. We started approximately at the NTU of 10 or 15, and also we ended with approximately 10, 50 NTU. So that indicates that the probe is still clean after 7 weeks operation and isn't disturbing the measurement. The wipers on the sensor are circulating before each measurement. As you see also that after rainfall, the turbidity sensor is responding really quick so that we can get a good view of the concentration of the turbidity and the EC, what the effect is of the rainfall. This peak is just a fish or a duck who was passing by, but normally, and this graphic indicates us that the sensor for turbidity is really stable, and also for electrical conductivity. We also have looked into the dissolved oxygen, which is being measured optical, and the chlorophyll A. Because of the photosynthetic, there is a relation between the chlorophyll A and the amount of oxygen. As you see, till the beginning of March, there was hardly no sunshine, but a lot of rainfall. And as a result, the chlorophyll A was only in low concentrations and had only little peaks. When the sun starts shining, the chlorophyll A peaks together with the oxygen line of concentration. And that gives us a good indication that the photosynthesis is working well. And as you see, still during 7 weeks, there's no decline in oxygen because of fouling of the sensor. And that is also a big advance against our former approach from Accurate. This sheet goes about the Scuba Mobile. It connects to the multiprobes on the water cable for any length up to 200 meters. The Scuba Mobile is connected to the probe and can transfer the data by Bluetooth to your mobile devices. So this gives you an opportunity to measure a lot of spots, a lot of measurement locations during a day, for instance, 10 measurement locations, and collect all the data from all the measurement points. And afterwards, if you go back to the office, you can log all the data via a log file, for instance, the CSV file, or you can transport it into Excel and make a graphic of it. It also provides the power to the probe and gives a wireless connection to a Bluetooth-enabled display. The Scuba Link app for display device provides control features, including sensor configuration, instant and automated data capture, and file management. But via the app, you can also calibrate the probe, register the GPS, have some geofencing, and more. And just it is a handy tool to collect your data and operate together with the probe. The data files may be emailed for convenience. The Scuba Mobile is ideal for spot checking, depth profiling, low flow sampling, lab use, and also wireless communication to cable reels. And here you see some pictures from the top of the Scuba Mobile with the battery live indicator and on and off switch. And you can also see the connection with the RS-232. We also have a larger handheld. We call it the Amphibian 3. It's an ultra-rugged field display. It runs on intuitive control software, and it has an Android 7.1 operating system. It's larger than, for instance, your mobile phone. It's some heavier, but it also contains a photo camera. There's a fast ARM Cortex processor, also EPI 68 design, and it is ideal for spot checking, profiling, low flow sampling, lab use, and downloading data from battery powered loggers. And at the right side, you see the plugins for several options, like an USB host or a client. We also have software, control software for PCs and laptops, but also the Scuba Link, as mentioned, for iOS and Android displays. I have one remark for that. The software is expected available in Q2 this year, and the Scuba Link app we expect to be that it is available in the Q3 of this year. In the next two slides, I have put on some PC screenshots of the software. Here you see the options for the PC. So you can set the scroll interval. You can set the snapshot location. You can take automatic snapshots. All the parameters you measure. So you get insight of the measurements of the measurement results of the different parameters. You have also an overview of the COM ports, and it tells you the control software version. The second option is the Scuba, where you can manage your Scuba files, your logging setup. The frequency as low as is 1 second, and you can higher up till 1 minute, 5 minutes, 10 minutes, what you want. There's also the option for a calibration log, where you can register all your calibration results. All the calibration results will be stored, so you can build up a calibration history of all your calibrations on time. So that if you want to look back for a year, you can look into all the calibration data. Another option is the sensor and parameter list. You can click on some sensors that you want to be active, and also select the parameter. The calibrate option is, of course, for calibrating all the sensors. It's just easy, and during the calibration, you get a graphic where you can see what the result is and also the stabilization of the sensor during the calibration. You can put in your calibration value of the standard calibration fluid, and also set up the first and the second point, for instance, for pH, where you have to calibrate on pH 7 and pH 4 and or pH 10. The Scuba version tells you, okay, and there are customized parameters to create them. You also see on the screenshot that there are also some buttons to start some other actions which you can use. The measurement results in the yellow marked row are the actual measured values. The values below in white are the values of which are measured in history. So just for in the last few minutes. In this sheet, I've put some screenshots of the Scuba Link app. These are not all the screenshots, but just for an indication how it works. The left picture gives you an insight of the home screen, where you can see the actual measuring results for the parameters. You can take a snapshot to push on a button, snap, or to clean the snaps, or to connect the probe. There's also on the right side log on and log off the sensor. Below you see some options like home, where you're looking now to, and also you can look into the files which are stored in the map folders. Sorry, you have the option for calibration and for settings. In the middle, I have a screenshot which gives you insight of the calibration menu. You can here select a parameter to begin. For instance, turbidity and you push on the turbidity and you are starting the calibration process by giving in the standard calibration solution. Also, after calibration, there is the calibration log, which is being stored in the app or in the PC, but in this case in the app, and you can export the calibration log simply by download it and email it to somebody. You can make different log files, as you see, and the app is just an easy tool to use in the field. Especially the black background and the white marked texts and numbers, it's easy to read it outside when the sun is shining, because normally it gives you less insight when you have sun shining on your tablet or your screen, and it is useful that you can read all. I go over to the articles of the probes and prices. The articles, we have the probes, including the basic sensors. You can also remove sensors or integrate the HDI12 in the probe. You can choose accessories or calibration fluids. Calibration fluids is wrong mentioned here because calibrations is here below. So I will delete this in later on in the presentation. We have extra sensors you can put in them, like the fluorometers. You can add cables and accessories. There are also some ICOCOM standard packages for field and online measurements. In the field and online packages, we have integrated the Scuba Mobile, and also the calibration fluids. The prices and article lists are available via our international account managers. As a product manager, I will set up the price, some steps, so that to fill in the price list. Thing I mentioned here, easily in 8 steps. The first step, you select the standard probe. If you want to add or remove some sensors, choose the second step to remove sensors or to add HDI12 Modbus. And in step 3, you can select extra sensors. In step 4, you can, in step 5, some accessories. In step 6, you can select calibration fluids. Step 7, an external, a battery pack, internal or external, or a solar panel. And in the 8th step, last step, you can select the modem if you want. And step 9 would be selecting an ICOCAM standard package, but that would also be a step 1A or B. Support at ICOCAM. at sales department, sales@icocomp.com. That is your central point of entry. I'm also available as a product manager water quality, and I work together with Marcel Lankrijer. Most of you know him already because he's longer inside Icocomp, and we cooperate and are supporting you for all your questions or problems you may have with the probes. Also, the Icocomp service and rental department is available for all your questions and to support you. Next steps for the introduction of the Scuba probes. We are busy with the documentation to translate it in your language, like the manuals, the brochures. The manuals and brochures are now available in English. But the coming weeks, months, we will translate it into French, for instance, German, but also Spanish. Also on the new website, we will upload the product information at ready, so that the product information is also available for the Scuba probes for all the distributors. If you need any introduction with partners or others, please call us and we will help you. And at the end, in the last quarter of this year, we will send you a questionnaire list to evaluate the experience with the new probes. Because it's just very important for us that all our clients are satisfied with the Scuba probes. So with this sheet, I'm coming at the end of our webinar. So if you have any questions, please let us know in the question box, and we will go over to the questions if there are any questions. I see that there was one question from Alberto. How many people are in the presentation? Well, at the moment, we have 25 attendees. So I think that everybody is online now. There was also a question, which is the minimum stuff needed to work with any Scuba, and also see that already Winnie has answered that question. Thank you, Winnie, for that.
Okay, you're welcome. Eric, I have one question. It's very general. How do we position ourselves, our Scuba probe, on the water quality market?
Sorry, can you repeat that question for me?
How do we position ourselves to the water quality market?
At the moment, just as a product company, but we are still moving more to a data delivery company. But there will be always a mix of delivering products and delivering data. Does that answer the question enough?
That means we are actually like a data supplier.
Yeah, I think when we are looking into the future, that will become more and more the case, yeah. But there will be always the question from clients to have probes to have their own property of it.
Correct.
Yeah? I see also a question: how does the PAR sensor attach to the probe? That is not on the way the most sensors are put on the probe. Yeah, so but the PAR sensor is put aside. Yeah, it's like a circle, like the image of a lamp. Yeah, and that is put aside of the probe. And if you want to know more about the PAR sensor, just let me know. We can send you over a picture. There's also a question, is there any chance to extend the battery power by combining the internal and external battery packs? That's a good question. As far as I know, that could be possible, but I'm not sure about it because it depends on the total battery voltage you may use. And the total battery capacity you may use is 15 volt. And otherwise, if you have too much voltage, it's not good for the motherboard and the sensors. But mainly you have enough with the internal battery pack or the external battery pack. In any case, both. For data delivery company, you need, like with Diver, is this in the pipeline? Yes, we have. We have our own modem. And that modem, you can use it to transport the data to a web portal. And as mentioned, you can also use your mobile device to get out a log file out of the data logger from the probe and put that log file into an email to your client or in Excel and put it in a graphic and send it then to the customer. What about competitors regarding prices? That's a very good question. With these probes, we are in the highest segment of the market, and we are competing together with YSI and in situ. And as far as I know, we have lower prices than in situ and YSI, but it's also strongly depending on the current market situation. Are there still questions left, Winnie?
I think, Uno, you still have some questions regarding our data delivery. Can you unmute yourself and then ask your question because I'm not clear? Uno, can you hear me?
I think you have all blocked the microphones, but I see his last question. You need the data on the platform. Yes, that is possible. We have a web portal, a platform, where we can put on the data and visualize the data to our client. So if you have questions on that, we can advise you how to arrange it. And we normally use our GDT Prime Plus modem to connect to the probe and send off the data to a web portal. And as I see now that the answering of the question is enough for Onno because of the thanks.
Yes.
For brushes, I see the smart sensoring brochure has been updated. Are there specific Scuba brochures as well? Yeah, we are in the process of that. We have a general Scuba brochure. That's not the smart sensoring brochure. The is really general for all the sensors we have. But in the meantime, we have made a special Scuba brochure. We can also put that on already, and if the website is okay, is finalized, we will also put it on the website, our new website. How many battery life? This question from Jim Andres Marin. That depends. The battery life depends strongly on the amount of sensors in the probe, but also the frequency and the frequency of sending and measuring. we have a tool to calculate the battery life. So if you are interested in it, we can put the calculation sheet on ready, or you can call our sales department and they can advise you how long the battery life will be. Normally, the battery life measurement and sending frequency between 1 month and 3 months. The par sensor we have answered. What is the minimum stuff needed to work with the Scuba? Any Scuba, please? Yeah, that's the standard package. A cheap option. The cheapest option is the 3 meter, and that also only can contain 3 parameters: the depth, the temperature, and any other sensor except the ISE. It would be good to see a cheap option, and it's to LATAM distributor mainly. Yeah, the cheapest option is the 3 meter. Okay, as far as I know, all questions have been answered. If there's any question left. Yeah, I see a question coming up from Harsh Agarwal. We want a system where the customer can view the data remotely on his mobile and can alert for low DO levels. Is it possible here? Yes, that is possible, but not directly. There is a way via our web portal. We can set on in our web portal alarm values, and based on that alarm values, we can put in alerts. And in the meantime, we are also have an app from our web portal builder, and that portal, that app, we can also use to alarm customers by app. Yeah, so yeah, it's possible, but and what is needed therefore? For what? I don't know what Alberto mentioning on. Okay. But what is needed? I think that Alberto is connecting to his earlier questions, but I think it's already have been answered. Okay. Are there any questions coming up? Alberto, the minimum stuff needed to run a Scuba. Yeah, the minimum stuff that is needed is the probe itself. You can use it as a data logger together with the internal or external battery pack. That is the minimum. And if you want to have it online, then you have to connect it with the modem, of course. And depending on the frequency of measuring and sending, you also need some more power delivered by a battery or in combination with the solar panel. Thank you, but please send us the detailed reply by email so that we can provide a solution to a prospect here in India. Yeah, we will. What we will do is make a small paper with all the questions which came up in the webinar, and we will answer the questions and we'll send them to you. So if there are no questions anymore, then I will thank you everyone for listening. And if you have any questions coming up from your customers or yourself, just send us an email and we will help you. I wish you everybody a good afternoon and also a good evening, and see your questions. Bye bye.